Right, so now we're going to look at our parallel circuits. Okay, now these are circuits where you have two loads or resistances that run parallel with each other, and they don't necessarily need to run parallel. What it does mean is that the current has an option. When it reaches this point here, it has an option. Does it want to go down the black path or the grey path, or does it want to go down the yellow path? Okay, now these circuits are extraordinarily useful. It's very important that we realise we've got special sets of equations for each type of circuit, parallel and series. And one of the first things we're going to do is evaluate this circuit. Now, let's assume again we're dealing with a 6-volt battery. Let's say we've got a 2 ohm resistor again and a 5 ohm resistor, and we're going to practice our calculation skills using these type of circuits. So again, nothing changes. The first step, find RT. Now the equation for parallel is 1 on RT equals 1 on R1 plus 1 on R2. And what we've got here is 1 on RT. Now it doesn't matter which one's R1 and R2, but I'm going to set my R1 as 2 plus 1 on 5. Okay, I'm going to use my cross multiplication method, and I'm going to get 5 plus 2 over 10, which is 7 over 10. So 1 on RT equals 7 over 10, which means that my RT, when I flip both, I get 10 over 7 ohms. So now I need to find step 2, find IT. I know that I'll undo that. V equals R times I. RT, IT, VT. And here we've got 6 volts equals 10 over 7 times I. I'm going to times both sides by 7 first. That cancels those two. And I'm left with 10 IT equals 42. Divide both sides by 10. Cancel again because we're proper mathematicians. And we get IT equals 4.2 amps. Which means, I'll just take us back to the diagram. This value here is 4.2 amps. Now, let's undo that one. And again, and again. Now let's go back to our diagrams. Zoom in a bit. Sorry, back to our working. Let's say I was asked to find the I1, which is the current through resistor 1. Again, I would go to V equals IR. Now because it's parallel, we know VT equals V1, which equals V2, which means my voltage will be 6. I don't know my current, that's what I'm looking for, times by my resistance, which is 2. Divide both sides by 2, undo those two. And I get I equals 3 amps I1. Now if I want to find I2, I do the same thing. I2, R2 current, V equals I can do I2, R2, V2 if I want. 6 equals, my I is unknown, times my resistance, which is 5. I2 equals, repeating, sorry. So my I2 equals 6 over 5, which would be 1.2. Now I'm going to guess that 3 plus 1.2 gives us our I total, which it should IT 4.2 amps, which I'll highlight here. So that is the resultant of what? I'll do that bad boy. Go to the yellow. That plus that, which it is. So I know that my calculations have been done correctly. So again, I relied on a couple of pieces of information I needed to know, and I'll do these over here. VT equals V1, which equals V2 in a parallel circuit. My 1 on RT is my total resistance, and that equals 1 on R1 plus 1 on R2, etc. And the last thing I needed to know was that IT on my current total equals I1 plus I2. I hope you've enjoyed.